discussed about what is data science and what are the major the features and so on, right? So now it's a time to jump into the machine learning. So there's like a bunch of algorithm. So by using a Python libraries, we are going to explore the given data to analyze the creating the model and playing around with the data, and then creating a model, and we are going to find out whether the model is stable or not. And then it's a long journey, yeah. Okay, but based on the curriculum, like so we if you take that, it's never ending process. It's a ocean. So any software, anything, generally it's a kind of ocean, right? So it's a bit and pieces are there, but in real time scenario, so based on the customer the expectation of the customers, the data pulse, so we used to implement the different algorithm and depends on the situation. Okay, so this is one of the interesting topic, and it's a very vast topic, but anyway I'm planning to consolidate, and whatever the main thing we can go through one by one. Okay, so I have created the required slides, and I have enough uh, um, demo as well. So we'll go through in another two hours, so that so I think you won't get bored. I'm sure about that. Okay, right. So machine learning. So so how many of you heard this word machine learning, guys? Evolved like almost 1959. The Arthur Samuel, like the American IBM guy, he found that terminology and started doing all other artificial intelligence things like very long term. This is a old terminology, artificial intelligence, but now they're planning to like they're come up with this new version of deep learning, computer vision, and NLP. So the sort of so many things are like they're much matured artificial intelligence what we are working on. Okay, actually, the data science is a way to towards the AI. Okay, so nowadays actually the AI is like is very leading the IT industry. So all the customers they want to do that, like they want to cut short. Basically, they want to reduce that manual effort, and they want to do it by the system itself. So basically, already in our at home as well, like we have the AI based system. For example, if you take your washing machine, so washing machine also we have that the programmed logical circuit inside that. So whenever is selecting the temperature and the kind of what kind of the wash you want to do, that you have to select, and you press the button, what it will do, it will go and select that option. So based on the instruction, it will rotate 10 times left and 10 times right, and then soaking that timeline 15 minutes, 10 minutes. And the same way, like top down, or there are so many varieties of washing machines are there available. They're internally they're programmed, and the things will started doing all those things. The same way, if you want to switch off the your television after some set of second, or you want to record something, so there are also comes across the AI only. But now it's like a robust way of doing all manufacturing industries like connected with the system, and they want to do the things are very best way. So that is the reason the machine learning journey towards like the AI is like nowadays it's going to be very famous, and there's a much talk about with all the things talking about like AI only. Okay, so in the session we are going to discuss about what is exactly the machine learning, what is the machine learning process, and high level we are going to discuss about supervised and unsupervised. There are so many things are there, we don't have enough time to go through those things. Okay, so it's a long process. So probably like going forward, you see, anyway we have that WhatsApp group, so we can share that details, we can exchange our knowledge. Okay, and here see it's a simple image is there, right? So the funny image. So human is telling I can learn everything automatically um, from experience. Can you learn? Then the machine is replying to him, yes, I can also learn from the past data with the help of machine learning. Okay, so earlier, very first classes, I think like we have discussed about that driverless car. So driverless car, what I said, like so we used to collect the data point from the different n number of drivers experience, and based on that we need to create a algorithm to to drive the car without any human interaction. Okay, so that is you can predict like the two things. Actually human is asking like whether you're able to do, automatically with from the experience means, so experience in the sense is nothing but for the machine is going to be data basically. Okay, so the things is going to be like this only. So we'll jump into that how the data science it's a part of the machine learning, and how the machine learning part of AI and all the things we will go through a few slides. Okay, so here so what is data science? I think already we discussed the diagram we have in left side, the computer science and the maths and science, okay, mathematics and statistics and domain knowledge. So altogether, we'll brought up that the what is that the data science. So the machine learning where it sits means your maths and computer. So it's nothing but your machine learning space, and then or right, basically what nowadays we are doing like developing an application, getting the knowledge from the customer requirements documentations we are preparing, and what we are doing, we are developing the application by using Java or .NET, whatever it is. So that is nothing but it's a software development. Okay, and the same way earlier days actually, so they want to do some statistical analysis or like doing some mathematical calculations. So manually they used to do, how they will do, they'll have a domain knowledge and business knowledge, and then they'll come back with the manual report. Okay, it's a printed report kind of stuff, or they'll handwritten report. So those things is traditional model. The traditional model is replaced by the software development, so that the system will take care of all doing like doing register reservation, for example, reservation of like train reservations. If earlier days, like very long back, they used to write everything. Everything in just a small piece of paper. They used to write Chennai to Madurai or Chennai to Nellai, whatever it is. They used to highlight that. But after some time, the systems have been developed. They'll just type that from and to. Then when what is the express Madurai Express or like Pondian Express, whatever that. So what they will do? So they will register reserve the ticket. So they'll take the printout. So that is nothing but what it's like a software development area. So now we are going to do in machine learning perspective. This is ultimately a different perspective, as I mentioned, and my friend uh, Amelia and Karthigayani, they said without human interaction, they want to do prediction. Okay, so ultimately we discuss about like to take the decision, or want to do the classification, or do you want to do analysis the data. For those things we have to have the machine learning. Software development going to be there only. Don't bother about that. The software development always going to be there. Is the new requirement or new changes we need to do that. But doing it prediction, doing like what is that? Find out whether the recommendation systems and all other things will come out using the maths and computer science. So based on that, we can create the machine learning algorithms. And in my right side, I have how the machine learning as well as your the data science is correlated. It's a very simple. So data science actually we have discussed about various data visualization and data preparation and everything. Okay, and this and when you go with like a machine learning, there are the three things are there majorly. That is going to be supervised learning, unsupervised learning, and reinforcement learning. Okay, the reinforcement learning is a big ocean. We are not going to concentrate on anything on during this session. Okay, for the complete curriculum, but supervisor learning and supervised learning, yes, we are going to discuss. Okay, so the supervised learning purely depend on the data science. What are the things we have discussed so far? It will consume everything in supervised learning. Okay, and unsupervised learning, it's a little bit away from that curve. So by using this Venn diagram, you can understand that unsupervised learning is like it will take almost a 50 to 60% of stuff from data science what we have discussed, and it will work on that. But reinforcement learning, nothing related, nothing related. It's like a totally independent thing, like not related with, we cannot related with the data science directly. Okay, nowhere is related to data science directly. Okay, but indirectly it might, because data perspective it might. But best example for the reinforcement learning is like developing what is that the games. Okay, so I don't want to discuss in detail, so because the concentration is going to be different way. Okay, so any questions here? Any questions here?
No, sir.
Cool. Thank you. Right. So, and this slide to talk about like the artificial intelligence and machine learning and deep learning and the big data and data science. These are the actually the terminology that is AIML, DLBD, DS. It's like nowadays a hot in IT industry. Okay. So if the people are having this kind of knowledge, they're really hot. So they'll come and pick up the guys like, so, okay, I want to develop the AI means so the AI architect and ML architect and deep learning architect is a high demand in recent years. Okay, and you're going to be another 5 to 10 years maximum. It will dominate. That's acceptation. Okay, and then the same way for big data, it's really required because actually, as we mentioned earlier, so each and every seconds the data, it's a lot, the data volume of the data is increasing over the net. Okay, so if you, as I mentioned earlier, if you're going to buy uh, anything from the shop, so the way you are traveling, for example, you are using a Google Map or what, Google Map or else GPRS, something like that. So what they will do, they'll capture your path. Okay, they'll generating that the where we are going. So you are finding the way. If I want to go from one place to another place, like for example from Chennai, I mean India, I want to go to T Nagar, or else I want to go to the Besan Nagar, wherever. So if I'm using Google Map, so the Google Map will give the direction for me. The same time, they will take my that data point and how I traveled, how fast I traveled, then which route I took, then how many people there took the same route. All the data will take up that. So if you're reaching some shopping mall, then immediately it will capture, yes, I'm there. Then I'm purchasing something. Yes, these guys purchase all those things. So after that, what happened? Like, what are the shops I'm visiting? What are the expenses you're doing? So it will easily calculate all the things. It take the data and it will give the back to the other people. Hey, so and so went here. They are happy purchasing. They happy shopping that place. Actually, they bought all these items. They are what is that? They given a feedback or what is that? Um, the rank might be like 1 to 5. They given a 5 for all across these shops, something like that. So they give a immediately they give the data to the other customer, then they'll ramp up their business, they'll increase their business. That's a main agenda and main thing. Okay, they want to clarify that just for business perspective. I'm telling the same thing for the other area as well. Okay, so the deep learning, it's a really challenging one and very interesting one, very advanced version of this machine learning. And machine learning, we are going to discuss about that. And again, artificial intelligence, it's like a combination of the machine learning as well as your deep learning. And some set of portions we are going to take it from data science. Data science is a part of the data. We are going to take it out, taking from the data science, and we are going to apply all our machine learning and deep learning as well. Okay, and right side I have some my the Venn diagram. It's a kind of circle diagram, right? Again, where it is, like, it's a different perspective. So there are so many things other, but anyway, all this circle, so like related with each other and some set of portions. But artificial intelligence and machine learning, and then the deep learning is a quite it's a kind of what is that, image classification or picture, audio or video classification, so they can find out. So I don't know how many of you using that the Google Glass. So Google Glass, you guys have tried any Google Glass so far? Google Glass. So for example, if even you can try that. So what you can do, you can take some picture, or you can have a picture of, for example, Taj Mahal. So you're not sure about like what it is exactly. Okay. So if you are in India, you definitely know like, okay, what's the place is that. So any angle, it could be any direction. If you take the picture of the Taj Mahal, then if you go with the Google um, 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 what is that, Google image, so you can zoom, Google lens, so you can find out so which place is that. So if you pull out that the glass, so automatically what will happen, it will pick the relevant images of Taj Mahal, and what are the all the images across the globe, resemblance like the Taj Mahal. It will pick up all that information and show it in the picture wise. Is a picture like Taj Mahal, it's in India, then Agra, whatever all the history you can find out. The same way, if you pull out like some image, some pictures like Modi, or else like if you're pulling out Manmohan Singh, or else any other politician or any other actors or actor. So if you pull out that, then if you Google Lens, if you find out that, they will pick up the relevant image and it will show who is this. Okay. The same way, in your Facebook, you'll find out like so it will say the person name, that's a tag. Okay, it will guess the answers. For example, if you guys are taking a picture as a group, four or five people, and all these people like among your friends, so the Facebook will give a suggestion. Hey, this is your friend A, B, C, something like that. So how it is possible? This is actually based on the deep learning culture. Okay, so by using deep learning, it will face recognized and will try to figure out who is who. For example, if it is going to be a dog is sitting on next to you, then it will say this is dog. And if the cat is sitting on the next to you, then it will say that cat is sitting on next to you. And same way it will say this is a human being, this is animals, and this is a tree. So many things. So all those things we can figure out, we can find out by using the deep learning culture. That's a very interesting, and there are so many things are there. It's occupying the entire world now. The deep learning engineers are really highly wanted, highly demanded. Okay, that's one thing. And let me go to the next slide. This is actually what we have discussed so far in a text format. Just I want to go through quickly. Okay, I don't want to read line by line because you may get bored, right? So as I mentioned earlier, data science is going to be a data visualization and data preparation, and then machine learning going to be a three-part. That is what like supervised learning, unsupervised, and reinforcement, right? So the data science is a broader concept and is a multidisciplinary. As we discussed about multidisciplinary is nothing but it consuming the computer science, statistics, probability, and so on, domain knowledge, so many things. Okay, so many things. And same way, if you take the data science general process and method of analysis the multiple data, sorry, manipulating the data. So as we discussed so many things about how we need to manipulate the data, right? So getting the data from the various source, and we are going to convert into the unstructured data into the structured data. Then we can keep moving on that. The same way, the data science is enables to find the meaning and appropriate information from the given data. That's nothing but insight. That's very important, guys. This all this each and every point is a really crystal clear input about the data science. Okay, so probably when you are getting any opportunity like the campus interview or off campus interview, probably you can say you know the data science. You learn data science. You worked on you did some small case studies with using a machine learning algorithms. So by the time if the interviewer if they're asking, so tell me about data science, means probably you can bring up this all these words. No need to go and um, read out anywhere. So just crystal clear, handy. You can take the notes on that. So you can say that. So it will be really good because actually going forward, the most of the project going to be in data science and machine learning and deep learning and so many things. Data analytics, basically data analytics. Okay, and then I don't read other things. Okay, it's a similar thing. The machine learning fits within the data science. Yes, of course. The Venn diagram it's predicting the same thing, and machine learning uses the various techniques and algorithms. Yes, that is the various techniques. Algorithms means like it's the various types of machine learning is going to be broadly high level is a supervised learning and unsupervised learning and reinforcement learning. So individually, there are the many subdivision under the supervised learning and unsupervised learning. So most of the things we are going to cover during this curriculum. Okay, so I'm sure like after this completion of the complete entire program, definitely you will get some holistic view of like what exactly the data science and the machine learning. At least 30 to 45 minutes you able to speak, I'm sure. Okay, and then machine learning um, learning is a highly iterative process. Iterative process means keep on doing that. See, guys, actually, how we'll get the in the first diagram, right? See, for example, in this diagram coming back, so the machine is telling, yes, I can also learn from past data with the help of machine learning. So, and the guy is telling, I can learn everything automatically from the experience. Can you do that? So the answer is here, right? So the machine want to do the certain action in iterative process means the learning curve. If you're doing some set of, if you're doing some algebra, or if you're doing a what is that, some integration calculus or integration, double integration, triple integration, whatever it is. So if you keep on doing the practice the max, automatically you will get the knowledge and the learning curve will build up. Then is any problem is given to you, you're able to sort it out, right? That is nothing but what? It's a learning. It's nothing but iterative process. So if you keep on doing some set of process, automatically you can learn more and you can do it own. That is nothing but machine learning iterative process. Okay, and then um, yeah, the other things model. I don't want to give everything like a model. Yes, that's it. So these are the very main key areas. Just go through yourself. So I don't want to read out each and everything. And then the main difference between the two is that data science as a broader term and not focus on algorithm and the data and the statistics. Okay, but also take care of the entire data processing methodology. That's very, very important thing. Okay. Any questions here? So today's session mostly going to be anyway, I'm planning to show the demo as well. Don't worry. Okay. So I'm planning to show demo as well, but it's going to be almost 80% is going to be 75% is going to be theory oriented, and the content actually today I designed is a really takeaway for you guys. The most of the things what we are going to go through in the code. So directly I can show the code to you guys, but some set of things I need to explain better way so that you can correlate with the code. Okay, that is very, very important, because actually there was some gap even when I was started my data science journey. By the time actually it was really challenge. It's like a reverse engineering process. Okay, so why we are using this one, why not we are using the, what is that exactly? So that's the reason actually I've created the content in such a way, so that even I want to add more probably in the next session, because the what are the bit and pieces things going to be in slides, and everything going to be in applied in your code, so that you can get the bigger picture and you get the clarity. So why we are using this specific syntax or specific line item in the code, that's very, very important. Okay, any questions here? Any questions here? Okay, I think you guys are clear. Thank you. So the machine learning, as I mentioned earlier, it's going to be supervised learning, unsupervised learning, and reinforcement learning. So please like forget about reinforcement. It's a version. It's like a really a big challenge. So I'm not like this is not going to panic one. That's like no. It's too early to discuss about reinforcement. Let's focus on supervised. What is supervised? Supervised is nothing but a task driven. Okay, there's some set of task has been given to you, then you want to predict. Okay, so here until you're getting that the correct answer, then you want to do that again and again. Okay, like for example, during your school days we used to have the dictation, right? So they used to give the dictations. It could be like English or Tamil or whatever the language you did. It's going to be like giving a dictation. So after the dictation, what they will do, they'll correct that the vocabulary they given. So they will check whether that exactly the spelling is correct, then they'll give the full mark. If there any spelling mistake, they'll ask you to redo that, right? Again, what they will do, they'll give some other set of vocabulary. So why they want to give the other one? Because already we're familiarized one variable, one vocabulary, so one word. Then again, if you're giving the same word again and again, means you're familiar with that. There's no point of giving the same word for multiple time for train you on that the spelling perspective, that's totally different. Okay, so the same way, supervised means someone has to be guide you, and they will give you the indication, hey, do this, do that, then you will do correctly means, then it will be correct, they'll give a mark. If it is wrong means, again they will point out, hey, this is a problem, rectify that. For example, the best example, when you're doing a salt analysis, the given salt, what they are doing, we'll keep on doing that salt analysis for to find out the till the what exactly the salt, given salt. Okay, is a sodium chloride or calcium carbonate, whatever it is. Okay, I forgot the name. So there are so many salt analysis. So zinc chloride or something like that. So by looking at the color itself, the people say, hey, this is a zinc chloride. Yeah, this is a this one, something like that. So uh, this is a kind of like the task driven program, and the data with the labels. Okay, data with the label means what? For example, I'll give a clear example later, one by one. I don't want to you urge with one. Okay, so you are giving input, and somebody will train you guys and we'll get the output. Is there any issues? Then we'll get back to that the again, and we'll correct it. And unsupervised means this is a data driven. Okay, what are the available data? Then we are going to play with that, right? And here mostly identifying clusters. Okay, clusters means, for example, in population, um, I have 100 people, then 50 people are they using Airtel, and 35 people are using the BSNL, and 15% people are using Vodafone. In this case, so we are creating. Initially, I don't have that clustering. So based on the unsupervised learning, I can segregate, I can group them under that some certain category by using unsupervised learning. Okay, here uh, just input and the output, and internally I need to change this one. It should be unsupervised learning. Okay, I'll change this one later. Okay, and it will find the, and it will find the pattern of uh, the data. For example, if let's take the population in city Chennai, then what will happen? Like, so for example, okay, so how many people are there? Let's like some crores and crores of people are there. For let's say 1 crore people. Okay, so in that, like, I want to find out how many people are speaking native language. It's going to be the Tamil or Telugu or Malayalam, something like that. And if you take here the London, so here in the London actually is a multicultural, people are going around here. So if you take the population of the London, then if you want to segregate, that means the people from Asia, the people from there is a high category wise, we can go with like um, Asian, African, or Chinese, or whatever it is. Like, okay, so all this category we can arrive that. So the same way, if you go with like Indian population, or it's going to be a Pakistan populations, or Chinese population, or it's going to be some African countries population, or it's going to be there from the European country population. So they want to segregate that people. They can find out some set of the clarity, and they can create the pattern. Okay, this set of people, they're working for this specific area. Yes, for example, if you take Indian population, the 90 percentage of people in UK, most of the people, they are working in IT industry, and 10 people are working in different way. Like, for example, 80 percentage are from working in IT industry, and 10 percentage there in working in medical industries, and 5 percentage are real what is that, might be there in finance, and 5 percentage of they're doing normal job, something like that. So if you want to do that kind of pattern, so that's really important when you are doing the data, which is nothing labeling. We don't have any labeled data. I will discuss about what is a labeled data and unlabeled data later. So if you want to do that, the finding the hidden pattern, so certainly we go ahead with the machine learning. Okay, unsupervised learning. Okay, so I don't want to discuss about much about training enforcement. I don't want to confuse you guys. So as of now, just park over there. Then probably, so we will probably you can explore later once you familiar with the supervised and unsupervised learning. Okay, cool. So This is the very high level the differentiate between supervised and unsupervised. Okay, so labeled and unlabeled. So labeled unlabeled means actually here, so we might have what exactly we want to find out. There could be like um, as I mentioned earlier, I'm not sure whether you're able to recollect like independent variable, dependent variable. Okay, so independent variables, it's obviously without any interaction, it will go ahead. Okay, so it will not depend on anything. But if it independent variable means it always depend on some other variable, because based on that variable only, this variable will grow. For example, if you have a car and car like engine capacity, if it is very huge, more and more, then you can get the more speed. Correct? You agree, right? You agree, right? So if the engine speed is very high, automatically the capacity is high, then automatically the speed of the vehicle definitely is going to be high. So something like that, like we able to figure out like what is the dependent variable, what is the independent variable. For example, if it is going to be if it is going to be like um, weather monitoring, like today if you say it's a cloudy, so then I'm thinking, okay, it's a cloudy means I'm expecting, okay, there would be a rainy today, or it's going to be sunny, then like, okay, I can say, okay, the expecting rain is really unrealistic, so that it's going to be the whole day is going to be the sunny day. So all those things labeled means it's nothing but you're going to be an independent variable and dependent variable. And as I mentioned here, the supervised learning is going to be a proper a guidance, is a kind of teacher. Like, okay, so they will come and teach you A for apple, B for ball, something like that. So you'll come to know, yes, these are the exactly what supervised learning or supervised learning. And explicitly learning model. This model, we are training this model, and we are trying to figure out, hey, this is the outcome you should come. For example, um, in one subject actually there was some test. Okay, so let's say it's a unit test, so unit test for electrical circuits and devices and circuits, right? So first there are the 5 different units. Okay, so there are going to be 5 unit tests based on unit 1, 2, 3, 4, 5, and there might be some certain questions will be asked. Then after the during the final exam, all the 5 unit and the questions might be repeat what you have attended during the unit test, or else it could be a new question, but it's going to be same unit, but which is not available, which is not come through like you during the unit test, right? Which may not. So explicitly we are training the model. These are the expectation. Do that, you will get the answer. Okay, so this is nothing but explicitly learning model, and it will predict the outcome and future. As I mentioned here, for example, if the expectation, okay, so if for example, uh, uh, the person preparation for the examination is very high, and he's covered almost all the chapters, and the expectation, predict he might get definitely 80% and above. Okay, and the same way, after the examination we'll evaluate his answer sheet, then we'll find out, okay, the outcome, yes, really he got he has been trained well, and he got prepared well, and at the same time he got the good result. Okay, so something like that we can predict. So for example, all the 5 units, like you got like 80, 80, 80, 80 marks, then obviously you can figure out, yes, during the final exam, this guy definitely get more than 80, 85 marks, right? So that is something why you can predict that. So here also we are going to do the algorithm, and then finally we are going to predict the how much the output will come, and we can match the both values by statistical model and algorithm model. So by using a statistical, we will verify whether it is like related to that output, and then the same way we'll run the algorithm, we'll get the output, we can compare with those things, we can figure out, yes, what we have predicted, that's exactly, not exactly, it's relatedly, like not very closely, we can figure out that. Okay, something like that. And the same way for unsupervised learning, there is nothing not labeled. As I mentioned, the population in the city, so there is nothing labeled, so we need to do that analysis by using applying that algorithm, we need to find out. So here is a self learning. So the predicting, like the picture itself, you can see, right? The machine is learning its own. But here in supervised learning, actually supervised learning, there is a teacher is on the near to the board and giving instruction to the guy, and he started learning. Okay, and here you're not going to predict anything or not finding anything specific. Okay, right. So we'll discuss more about like what are the use cases we are going to discuss with the supervised learning and unsupervised learning probably next class. So I have the other slides for you guys. Today we'll discuss. Okay, and if you're going with the mission learning, supervised learning, and unsupervised learning, here I given regression and classification. When you go with the supervised unsupervised learning, there's a clustering and dimensional reduction. Okay, these are the again bit high level um, category under the supervised learning, but underneath we have subclass. Don't think like panic or like, oh, it's not good, don't get bored. But each and every regression models, it's going to be a particular to use cases. The classification model also depends on the different use cases. The same way for clustering and same way for dimensionality reduction. Okay, but very high level, what is machine learning? Two learnings like supervised learning and supervised learning. In supervised learning, we are going to discuss linear, classification, clustering, and dimensional reduction. Don't confuse yourself. Be clear. Go one by one, something like that. So I think you guys are done. Like even for complex circuit theorems, right? There are so many theorems are there. It starts with simple Ohm's law, and it'll go beyond like Thevenin's theorem, Norton theorem, right? Superposition theorem, and so many theorem. I'm not able to recollect all the theorems right now. So there are so many theorem, but each and every theorem, we have some basics thing. Then like based on the given circuit, we'll able to analyze that circuit. Then we'll do all this, right? Okay, fine. So now I want to jump into the machine learning process instead of going to the directly to the supervised learning and the linear regression model. Under that regression, we have linear regression and multilinear regression. So many things. Straight away, I'm going to that. Really, really, you guys will jump. You guys will be like confused. Okay, so now let me go through some set of process and key terminology, whichever it's required for to understand the machine learning process. Guys, actually, this is a very common across all the machine learning and the algorithms. So that I'll jump into this specific space, and I want to give the clear picture about what exactly the machine learning process, and you can go ahead. Okay, this is common across all the algorithms. That's the reason I don't want to go into that directly to the linear regression model, classification model, and dimensional model. No, before that, you want to understand what exactly machine learning process do. This is common across all algorithms. That's very, very important. Okay, so just keep in that mind so that you can understand very well. There are some there is a relations between the machine learning process and what the different methodology we are going to discuss, so that you should connect all these things when you are going through the code. That's very, very important. Okay, right. Let me go through this slide. Here we have a data collection from the different source. As I mentioned earlier, to collecting the data from different source, it could be audio file or video file or log file, or it could be anything, any application output or feedback, whatever it is. You get the data, and what you are doing, all your big data engineer or your Azure data engineers, they will do all the data collecting the data, and they'll create like unstructured format into structured format, so that you will get one consolidated view of data, right? So collecting the data and then giving to this data cleaning process. So we have did like data explanatory analysis. I have a separate slide for that as well. And even earlier, I think we have done few things. Okay, data explanatory analysis, that is EDA. So after that data cleaning, so what we'll do, we'll have the clean data set. Okay, and then we are going to apply the algorithm on top of that, right? and same time, so we need to figure out there is a one loop should be there. That is so here from model verification, and then again we want to do fine tune of the data. There should be some feedback loop. In your control system, you have a closed loop, right? So the same way, so from here to here, we're supposed to have the one loop here, so that we can strong enough to get the model to strong enough to get the accurate result. So after applying the algorithm on the clean data set, so you will get the proper model, and you need to validate the model evaluation. Okay, so we'll discuss about the model evaluation techniques later. So once the model is evaluated, then we want to pick out like best one, and then we can apply that prediction, and you can find out like okay where we are going to be. So this is a very high level the process diagram for machine learning process. Okay, and here the steps I have written in pictorial representation. So the collection of data from various source, and we are cleaning data cleaning and future engineering, and then again building for selecting a correct manlog. Sorry, there is a correct machine learning algorithm. Okay, the manlog actually is where I'm working. So my domain is a manlog. So usually used to call ML. So when it's come to the ML, then I'll automatically my brain is coming to that to manlog. That's the reason. Okay, so the correct is the to selecting the correct machine learning process algorithm, and after that applying that your machine learning algorithm, we need to evaluate which algorithm is the best for the data size. That is very important, guys. So very early stage also I'm giving this feedback, because as I said earlier, like during my journey, even I'm not clear about like why we are going for evaluating the model. Okay, so x to y to z, something like that. I put up these what is that, like, a point end to end, but not like that. Because if you take some data set, it could be fit for any type of ML algorithms. So, but we have to give that output to the statistician, or else like our vendor, saying that these are the outputs from different model, and this is the best one, so that for your data model, this is the best machine learning algorithm, so then go ahead with that, right? So those kind of evaluation we can do when you're doing the evaluating the model. That is also very important. So I'll try to cover that as well. Okay, don't worry about that. The same way, after that evaluating the final model, so we can go and deploy your model and the production. This is the overall picture of the machine learning process, and what are the very high level steps. Underneath there are so many written pieces, very huge varieties of steps are there, but definitely I'll cover very major steps which is sitting inside the each the steps which I'm showing here. Okay, it could be collection of data from various sources, and the cleaning the data, future engineering, and building model, and evaluate model, and deploy model straight away. You can deploy. That's it, simple, right? So do you have any questions here?
Sir, what are all the parameters that are generally required to see that it is the best model in order to determine that it is the best model in terms of the ML?
Yeah, yeah, that's what actually we are going to discuss everything in step 4. Okay, so evaluation of the model, that might be like the how it's like predicting the values. That's a very answer is going to be a very huge one. Okay, so short answer is going to be during that evaluation model step 4. So we are going to discuss in detail. Okay, there are so many parameters are there. So we need to consider all the parameters. Then we have to apply all these parameter. Then we need to find out like which one is the best for the given data. Okay,
Okay, sir.
cool. All right. So here I have that the machine learning process model again. The improvements, model improvements. So here I have the data processing and preparation and future engineering and model selection and modeling, model evaluation and measures, right? So And again, all these the key areas we need to keep it in our when we are doing our building our machine learning algorithm. We have to incorporate all these things, like we need to concentrate on data processing and preparation, and we need to keep on doing the feature engineering, and we need to do like a model selection modeling. Okay, sometime some X algorithm will not fit for the given data, so that we need to move on to the other algorithm. Or sometime today the model will be fitted to that specific algorithm, but tomorrow the date that tomorrow that model will not fit for the given available data, right? Because actually is a streaming data. The data which is from the streaming the data, it could be, for a best example, um, there was a one controversy or one hot topic in Twitter, right? So the data from in the Twitter, that like will take the by using some API, we can take that the data and we can do that analysis. Okay, so during that analysis, there might be like some sort of algorithm is fit today, but tomorrow, if I want to, the request might be like I want to analyze a different perspective or different angle. The what yesterday I deployed in the production is not fit. Immediately I need to ready to give the new model for the requirements. So such a way dynamically we need to change, and dynamically we need to predict that. Okay, that's very important. And and here I have that the bigger picture of the another flow diagram of the process. Don't confuse yourself. Simple thing. This is going to be all the steps what I've discussed here. But here I have just only the few things, cross validation. Okay, so we'll discuss about cross validation and the other bootstrapping method I will detail. Okay, so but for understanding perspective, now itself I'm throwing these words. Just keep it in your mind, so that when we're discussing all those terminology in detail, so that you can relate that why we are using this one. Okay, so the cross validation is mainly to find out whether all the what are the models it fit. Okay, whether this model is fit for this or not, so we can cross validate with the given data. Okay, that's very important. And same way in machine learning process, so the data processing, future engineering, data split, data split and the data set, and then applying algorithm and model validation and deployment. These are very key steps in machine learning process, very high level. Okay, so any questions or anything now? Because actually shortly we'll go to the um, simple demo, because here have data collection, data preparation engineering, and data split, training ML model, and ML validation deployment. We have steps. So each steps we are going to discuss at least a little bit deeper, but it has it has own deeper depth. But we cannot go and do all the things or kind of R&D for given timeline. Okay, right. So the data collection, as I mentioned here earlier, that's going to be like it could be online, or it could be a paperwork, or it could be a log, or it could be from application, or whatever it could be, right? And here the media and online and in-house and survey and feedback, all these items will gathered, and we'll prepare all this like semi structured data into structured data, and we can go ahead for what analysis. And here we have the primary or secondary um, data collection streaming. One is going to be in-house and unique problem. The available thing, whichever available, um, we can go ahead with that. And then secondary thing, available data on web. Okay, so first of all, if you want to take a decision, for example, if you want to take a decision, let's say um, in some in some office we have a cafeteria, right? The cafeteria, there might be a people, the mixed population, like they want to have a vegetarian or non-vegetarian combination. So always if they are putting that vegetarian means, or always they're going with either one. By the time they can find out the sales or interest of the individuals, so they can have a survey. So what they will do, they'll give a feedback or survey in among the employees. So they will give the survey like they want to have only the vegetarian or non-vegetarian or both. So they'll get the feedback and immediately they'll go for decision. Okay. And the same way, secondary options, for example, they want to do some benefit to the employees. They want to compare with the outside of the organization how the other employees are doing for their employee. So what they will do, they'll go and get the data from outside. They'll do the evaluation and they'll compare with the in-house data. Then they'll go for good offer for their employees. So that's the way we have two different things like primary and secondary data collection perspective. So once they collect the data, we'll ready to go for data processing. So here we'll go directly to this diagram here. Okay, so why I'm given this diagram, this is because during the EDA, so what are all things possible and what are things we are going to do. Okay, so the previous slide we discussed about the high level process. Now we are discussing individual items, loading the data. Okay, fine. And distinct the attributes, that's nothing but finding out like what attributes we need, which attribute we don't want, something like that we can decide that. And univariant analysis and bivariant analysis, and then multivariant statistics we can find out. And then the same way, so we can detect them here they actually, so I don't want to say steps here, but the step 3 could be like missing value, finding missing value and other things like so we can do it before doing our univariant or bivariant. That's fine, not a problem. But either way, vice versa, right? And after that, finding that our missing value, we can find the outliers. Outliers, as I mentioned earlier, like unrealistic data if it is in our given data set. So what you're supposed to do, you're supposed to minimize that outlier either by using a minimum function like main function. We can reduce that volume. Instead of removing that, you can make like closer to that the normal range. For example, CGPA, right? So CGPA model, for example, a person he got 9 out of 10 means he is a yeah, S grade, and the person who got 6 out of 10 and 5 out of 10 and 4 out of 10 means no other go. So we have to give them like internally we used to discuss with the internal they will discuss. Then they'll go for A grade, or they won't remove they won't give the A grade. They'll go with the B grade and C grade and D grade. And even sometime okay. So even though they will consider the 7 as a um, uh, 7 or 6 as a B A grade. So what they will do, they will, based on the available data, they'll segregate, they'll do the analysis the same way. So here we want to do that doing the outliers, removing outliers. So sometime it's going to be unrealistic date, that what I said earlier, like that in data entry, doing the data entry there might be some issues. So that so that's going to be very challenging to accommodate the specific data point. Then very well we can remove that. Okay, so we have some other engineering features, future engineering is also that. So we'll discuss that later in detail. I have even I have some coding for that as well, so we can discuss that later one by one. Okay, so this is the actual the process when you're doing collecting data and doing bivariant analysis, univariant analysis, bivariant analysis. So to do all this analysis, you can identify the what is the depth of the each data, each features. That's very important. Okay, and in the tab in this text way what I've given. So I don't know read out everything. Key thing, understanding the given data set. Okay, wait. Okay. Mm, yeah. So this point is very important. Third point is very important. Okay. So extracting the essential variables and leaving behind or removing non-essential variables. That's what I mentioned earlier. For example, if you're going for applying the machine learning algorithms in your table, let me take some Excel sheet. Okay, so this is my Excel sheet. Okay, so here I have fixed acidity or volatile acidity. This is just one. It's a Excel. This is a CSV file for weather report. Okay, so if I'm using this one, so I need to figure out like which column is really important or not for my analysis. Okay, sometime the quality might be not required. Sometimes quality could be very important role, or sometimes the pH value is not required, so that I can remove this one for the analysis. Or sometimes it's a total sulfur oxide column not required. So we need to analyze the each and every column, and we need to figure out whether this is really required for the analysis or not. That is nothing but what extracting the essential variables and leaving behind or removing the non-essential variables. And as mentioned here, handling the missing values or human errors, that's a very important thing. And identify the outlier, and figuring out the way to remove or taking into the account by using the different methodology, that's also very important. Okay, and EDA process would maximize the insight of the data sets, because if you are unnecessarily, if you are removing the data, or if you are not doing all those activities, so data will be lost. So once the data will be lost means definitely you cannot do the prediction. That's very, very important. Correct. See, for example, one cricket player, he played almost five tests actually average, and rest of the 20 tests actually didn't play well. Okay, for example, here and there, something like that. If you exclude all this, the 20 test matches from his analysis, what will happen? We'll take only the 30 test matches in account. If you come up with the average of the player, the report, that is unrealistic. Correct. So, so what happened actually? The same way for the candidate actually in specific constitutions, like the guy actually is in the election last past 4 5 elections, he win that specific constitution. So in that case, he's a reliable person. You can keep again, you can give the nomination for that guy. Okay, we can support that guy. So we can take the average of the person, like the winning portion. For example, last 5 years, the winning portion is going to be like a gap, like a difference between that the other guy. So we can find out the differences. For example, 5 years, okay, 3 times we win consecutively win this specific place. So the first time he win almost some 10 lakhs, and second time he win almost 5 lakhs or 2 lakhs. Last time he win that election almost lakhs. Okay, it's a 1 lakh or 50,000, something like that. So we need to think about whether he's the right person or not, because the last three election, the reputation of the specific candidate, it's keep on like going low, like the reputation on this guy is not at all good. So that we need to think about whether we can nominate this guy, or we can give this place for this guy or not. So that the way we need to analyze that. So even nowadays, even all the political parties or everybody in across the globe, they are doing all the data analysis, based on the history, and doing a lot of survey. Even separately they have running the separate office to do the analysis, to predict the guy able to win or not, the guy is the right choice for this selection or not. Okay, the same way in cricket match as well, right? So the last 5 matches actually, if Virat is hitting century, definitely in the sixth match they will say, hey, look at that last 5 matches, his performance is very high, so that we can take it account, like we can keep this guy. Anyway, he's a captain, that's different story, but we will keep this guy in the next match, this match. Or else they'll took some history, they'll take some history. For example, if you take English conditions, actually, Ganguly and Dravid and all, like, they used to play very well, right? Even though they are not in the squad for when they're doing on other continent, what they will do when they're coming to the English grounds, what they will do, they'll pick up those guys, because based on their yearly experience, they are very much fit for this. How they are doing all this prediction, The same way, there was one time actually, Sharad, like this guy Ganguly is not at all in the squad, but they are in I think they are in South Africa tour. So by the time they took his the complete analysis on that, critically we need some resource, some there was one person is not able to play, so that's the reason actually he picked. He separately called out. He's not on the squad when they're what they how they did the analysis. Okay, the same way the data is very important to analyze, to predict the even the human being, they're able to perform well or not. So if the data is like helping to the earlier data is helping even for predicting that human being nature, the same way for it's giving the detail into the machine, that machine will understand that inside of the data and it will predict something. Okay, something means it's predict closer to what expected. So that is the reason they'll fine tune the data with all the process, then they'll come out to the exact result. This is not as simple just like that. Okay, getting the requirement, developing the application and testing the application and giving to the UAT and moving to the production, that's different storyline. But building that model, it's really kind of R&D. Sometimes we might need the require the more data. It's a very important. Okay, so the data science and machine learning projects going not going to be starting today and ending tomorrow. No. So because actually we have to train the model, we have to get more and more data, then we go for deployment. That's very important. Right. So now we'll discuss about the future engineering. The future engineering, it's going to be like a missing handling the missing value variables and convert the categorically into numerical, since the most of the algorithms need the numerical features. Hope you guys are know the categorical variables, right? So we discuss about different variables. During the variables we have discussed like what exactly the categorical variables and how we are going to convert into how we are going to convert into the algorithms, like the numerical categorical variables to numerical variables, because to do the analysis we need all the data points supposed to be a categorical. Okay, sorry, going to be numerical. And the same way we want to correct the data, and we want to have the data needs to be distributed properly, then only we can go ahead for the analysis. And the same way outlier, it's playing also a very important role. And scale the futures. There are the other scaling methods are available. Scaling methods nothing but boosting the gap. For example, if for example I have, right, so for example if I have, I'll go this one. I go the data 10, 10, 20, 30, 90, 100, 150, and 250, something like that. So let's say if I have the data range like this, I cannot say this is outlier 250 or 150 outlier. No, because the data is already very less, right? Just for example, I'm saying. So what I will do, I cannot go ahead with this the same culture, because the same data series of data, because there might be a prediction or it would be really hard to find the exact accurate value. So for this, what I will do, I will go with this scaling up model. There are other portions are there. I will explain this later. So what I will do like I will create the given data set, the given range into be normal distributed across the range from 10 to 250. So by the time I might have a number of numbers in between, or else like I'll make like correlations between the two other variables, and I'll create a separate row, and I'll go with the for analysis. So those things we are going to discuss when it's going to be scaling the features. Okay, so we can scale up that. Otherwise, it's really unrealistic values. But I cannot remove that value. Even I cannot take in account the the value into the account. So it will be really challenging for me. So that I will do some scaling up, scaling down. Some features are that we can do that. Okay, so we'll do that later. The same way for like future engineering is expensive and time consuming process, and very very important, because before going to apply your model, your algorithm, you have to do all the process. Then only we have to go and do our applying algorithm. We'll get accurate value, so we can find out whether the given data are correct or not. We can predict something. We can do the categorization, everything possible. Okay. So after this, probably we'll take a small break, and before that, we'll have um, what is that independent and dependent variable. So I think already I given an instruction like what is going to be independent dependent variable. Um, Even today's also I discussed that, and even during the earlier class also I discussed about like what's going to be a um, dependent variable and independent variable. So dependent variable, independent variable mostly. So we want to understand this is only applicable for supervised learning based on my understanding. So the dependent variable and independent variable culture is mainly when we are dealing with the what is that when we are dealing with the supervised learning, and some sort of classification model also we can use that in our unsupervised learning. But anyways, so dependent variable and independent variable, right? So the dependent variables is always going to be a keep on changing on its own. For example, um, so what example I can give here? uh, yeah, so for example, right, so there is a plant. Okay, so if you want to grow the plant, means there are the other the key factors to grow the plant. It could be a surplus water, sufficient water, not surplus water, sufficient water, okay, to grow that plant. And sometime it required proper sunlight, and sometime it requires some moonlight, and sunlight, some kind of ventilation. If you are keeping the plant inside your house, okay, in the room or living room or kitchen, wherever it is. And sometime it requires some fertilizer. Okay, so the growth is a completely depend on all these independent variables. Do you agree? Correct. If you want to grow the plant, you need all these variables required to grow the plant properly. We need proper, what is that, soil condition. We need proper sunlight, proper ventilation, and proper moonlight sometime, yes, of course. And we need sufficient water, and we need fertilizer. Correct. So all these factors, it's really required for to grow the plant. So the growth is dependent variable, and all other factors going to be independent variable to grow the specific plant. You guys are with me?
Yes, sir.
Perfect. Perfect. So here I'll try to bring up something related to your guys. It's a variable resistors. So the variable resistors is used to, like, so you can change your the resistors value so that you can control the voltage or current, isn't it? Correct. So the variable resistor, so by using a variable resistor, so you're changing the variable resistance value here and there, right? You will get you can control the voltage or current flowing across your circuit, right? So here the voltage and current are dependent variable, and resistor is nothing but an independent variable. You got it? You got it? It's clear? So the independent variables always dependent on independent variable, because the each and independent variable, it will grow it is own. For example, dependent variables, it's being measured. The growth of the plant you are going to measure means, yes, how we can measure the plant growth? It's supposed to grow. right? Then what are the parameters what I discussed? Everything need to be aligned so that I can get the growth in the plant, correct? And the different variable what is going to be analyzed or predicted, right? And if you want to go ahead in machine learning path, if you want to if I want put a graph. Okay, this is going to be x, this is going to be y. Okay, so your x variable always going to be your independent variable. Okay, and y variable going to be is going to be your dependent variable, right? And then this is independent variable going to be observation, and your dependent variable going to be explanatory variable, and your independent variable always going to be a response variable, and your dependent variable are going to be predicting and predictor variables. Okay, this is very important things, because when you're going to discuss the deeper version of like the analyzing, like what you want to segregate, that like you want to group the independent variable aside, and you want to make segregate, like take it out your dependent variable separately, then only we are going for our modeling. That's very important. So we want to identify this is the variable for the dependent, and these are the variables for independent variable. So, and before that doing analysis, yes, we need any other key factors will impacting the dependent variable, we can keep those variables as a independent variable. If it is not at all usage, we can really remove from the data set. We can go ahead for your analysis. Clear? Clear? Okay. So here, and most of the things going to be your y is equal to mx plus c concept, but next week class only we are going to discuss like about exactly how this is related, but it's completely mathematical. I don't know whether I can go ahead with this one. I don't want to confuse you guys. Better you can go through. It depends on the timeline. If try to incorporate that, otherwise like we'll miss out the key factors. Okay, so y is equal to mx plus c. So this is a linear equation. Probably you have studied in algebra. So this is going to be uh, and this is going to be the key factor y is equal to mx plus c. So we need to find out the accurate value of the y by adjusting the m and c values, and we'll get x is a given value, and by using that equation we'll solve this y is equal to mx plus c. This is for a simple linear, and same way you have multilinear, that is going to be y is equal to x1 m1 plus x2 m2 plus x2 x3 m3 and so on plus c. So I think you remember very long back we have did some small discussion on this one. Okay, so let me go back to just a few sample code, then you go for a break. Yeah, yeah. See, this is actually my code, simple code, right? And I have the weather CSV file, right? There are 12 columns, right? I have fixed acidity and volatile acidity, citric acidity, so many things with respect to the weather condition, weather things, and I have the other values as well. Okay, so for this, I'm going to figure out um, what exactly. Uh, yeah, so I want to find out the y, the quality. So the quality variable, it's going to be a quality here. Just you can compare this two items what we have discussed so far, variables. Okay, so that it will be easy to understand. Okay, that's very important. One second. See, I'm really struggling here. Oh my god, I'm not able to miss this. Anyways, I'm trying my best. Okay, so what I'm doing, like for my x is going to be always my independent variables, and y is my going to be my dependent variable. I'm going to find out the quality of the specific thing with available factors, going to be all these values. Okay, so all the values will be given in our data set. So I'm after how I'm doing that. Just this is my given data set. Okay, so I don't run it again. So I'm loading this weather, and shape is going to be almost 12 columns, and 1599 rows are available, and this is a description. So just I'm getting like what is the mean, mode, etc, etc, etc. Probably I'll give one more step here. Mhm. Okay, one second. One second. On. Okay. So when I'm running this one, I'm getting my data, all this data, just header, very well. So I'm checking, is there null value, is there anything, because I want to remove that. So I have separate slides, separate code for you guys to how to do all the filling that, handling the missing value. I think already we discussed. And same way here, the another method. So I'm doing, like for fill, to fill the like the methods by using like removing all the null values. And so here I'm making a by separating my independent variable and dependent variables by using straight away, right? And then I'm just selecting my quality value, quality column for my um, what is that, my analysis. So I'm extracting this only the quality to my y, and the rest of the values in x. So this is how I'm doing my what is that, I'm going to analyze my data point. So this is nothing but the independent and dependent variable segregation. So I'm stopping here. So we'll come back after 10 minutes break. Is it
Yes,
okay?
sir.
So now we are going to discuss about the data split into train and testing. Okay. So right. So we have collected the data, right, from the various source, and we process the data by using different technology like a future engineering, what outlier and removing like um, outliers and missing value, all those things. And top of that, actually, we have identified that independent and dependent variable, because we have to figure out the independent dependent variable before we split into the data into the training set and data set. Okay, so the diagram itself, you can understand that. So during that model, as I mentioned earlier, for example, so conducting the test in the 5 units. So there might be a unit test 1, 2, 3, 4, 5. So 5 different unit tests. Okay, so I can take this example for even for my k-fold algorithm as well. Okay, that's we'll discuss later. So for example, let's take I have 100 MCQ. Okay, I have 100 MCQ in one subject. Let's say your electromechanical theory, I have 100 MCQ, right? In that, what I will do during the training session, right? During the training session, I'll take almost randomly, I will take, or sequentially I will take and share with you guys to give the answer, proper answer or not. Okay, so I'll train the student like way, and then during the test I'll go for uh, another 25 set of a percentage, like that test set. I will give the test set for do the testing. So I want to figure out whether I'll get that proper the output in that, so that I can say the model is stable and I can go for further 100 MCQ for my model. You got that, right? You guys are with me. So because it's a very important thing, because that's what I'm, as I said, see, generally how the flow will be happen, directly, like machine learning types of machine learning, they'll go for supervised, and they go for linear and logistics, blah 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 blah. Then finally there might be a bit and pieces, but realistically, like we're going to be in a real time scenario, we want to understand all the aspects before we jump into the pool, right? So you want to go into the swimming pool, what you're supposed to do, you need to have the goggle glass cap, and you have the proper swimming dress, everything, right? And if you want to if you're going to swim in the ocean, you want to apply some chemical something on our body, so you should prepare on that. The same way, when you're getting into that, the complete the processing, we want to get ready or prepared for this one. That's the reason actually I like uh, clearly I want to understand, you guys want to make understand the specific pieces and work. So data collection, this is now complete part of data analytics group, or our data engineer will make that. During the data processing, data engineering, we need to apply our knowledge, how we are going to make our data, we are going to get ready the data for analysis. After that, we are going to separate, we want to separate the data training model and testing model. Okay, so we want to do separate the training model and testing model. So during the before training the testing model, we need to identify the independent variable and dependent variable, right? So coming to this here, the full data set is one, and training data set and test data set. Training data is the data set on which you train the model. Okay, so you're going to train the model, whether you try to get the output, what exactly output. Okay, and then train data from which on model has learned and experience, right? So how this guy is telling, right? This guy is telling, right, in our previous things, like so yes, I can learn from the past data with the help of machine learning. So how will learn this one? First of all, you want to learn and you want to execute, right? That is the reason you are calling out as the, the train the data on which the model has learned and experience. Training set are used to fit and tune your model. So we want to give that the set of data. For example, if you have um, 10 rows, okay, let me go back to that Excel sheet. Okay, so let's say here I have a 10 rows. Okay, so what I will do for my analysis, I'll go, um, since it's a less just 10 data 10 rows, I'll go only for 5 or 6 rows for my testing, and for rest of the 4 for my training. Sorry, training and testing. Okay, so first 6 rows going to be a training, and rest of the 4 going to be more testing. After that, what I will do, newly I feed all this 10 data or 100 data to analyze the further analysis in my production. Okay, So when we are preparing the data for training and splitting your model, we have to very carefully choose your data. That's the reason we need to do all the fine tuning. This is applicable for your your real time, like the on production model as well. Okay, so test data, test set, test set, test data is the data which is used to check if the model has learned good enough from the experience. Okay, it got into the train data. So the test data will always get the learning from the train data, and it will work on that. And straight away we can say the test set is unseen data to the evaluate the model, because when we are evaluating the model, obviously what we are doing, the 70 percentage of the training the data only we are exposing, the 25 percentage we are not exploring exposing. For example, as I mentioned, 100 MCQ, in which like 60 MCQ we are we are doing training hands on doing the classes. Okay, and I'm taking another 35 MCQ during the test. Okay, then by the time you will understood, for example, I have 100 different problems. I am making you guys up more and more training, so that the test will be easy for me to conduct. Okay, so if I have the 100 problems, 60 problems I'm giving to you guys during the classes, so you guys are doing hands on. Then during my unit test, what I'm going to do, I will give the rest of the 35 problems. Definitely what are the problems I've given during we have done during our classes. I'm not going to give those things, because already we have been trained. So the similar kind of data we are going to test during our test set. After this is completed, I bring up the another 100 or 200 or 300, whatever the range, to our actual model, so that it will give it to you. You guys are trained and tested. So finally, you are ready to accept any kind of inputs, any kind of model. You can do the like solving the problem, right? So how you are doing our mathematics in class session, you are doing one set of max, and same time you are doing like taking up books from your library, doing something, some additional problems. So everything's get ready that. But when you go into the final exam, there might be a questions, the new problem that made they'll fix to that the number will be changed. Instead of 5 there might be 8, instead of 8 there may be a 10. Okay, there might be x or there'll be 2x. So something kind of something like that. So since you have been trained in your during your test, unit test, whatever it is, so during your final exam, let's consider final exam is nothing but your production, right? So when you move into the production, so everything will be easy, because already we have been trained and we have been tested and we have been deployed. So all set, so you can proceed. But there is a normally we have training the data set 75 percentage and 25 percentage for testing the data. Let me pull out my code. I'll show. Okay. So here, what I'm doing, uh, as I mentioned here, this is my independent variable, dependent variable. Okay. And I'm here doing what? X train, X test. Y train, Y test. That is nothing but X train, dependent variable. X test, sorry, X test, independent variable. Right? Right? 1 minute, I wish a bit confusion. All right. So X variable is going to be your independent variable, and Y your dependent variable. Okay. So this is nothing but your independent variable yeah, train and test, and this is going to be your dependent test and train data set. Okay. Let me see how many values. This is my data set. Okay. So let it be, how many rows are there? 1500. Okay. Let me put something 100. Okay. So I have 100 data. Okay. So So physically, you want to see where it is there, how this is going to be segregated. I'll show you guys. Right. So here I'm giving my, and before that actually training underscore test underscore split x comma y, test size is equal to zero point 0.2 is nothing but 2080 portion, and random state 5 10. We'll talk about this later. Okay, at this moment. So what I'm giving, this is my train and test and split underscore test train underscore test underscore split is a function which is available under your sklearn. Okay, it's a scikit-learn, right? So you have the model selection, and we have a method called class like a train underscore test underscore split. So I'm creating this one. So I am passing this value. What are the values? My x value and y value. This is nothing but what? My independent variable and dependent variable. Okay, this is my x value, right? And this is my y. So what we have declared there, quality, and other variables. Here we have declared so many variables, right? So I don't want to mention anything. So here I have bunch of rows, sorry, column value. So I'm feeding here, and test size is going to be at 20 means 0.2 means at 20, and random state is 5. Random state is nothing but CD is going to be at 10. I'll explain that later. So when I'm giving this one, I'm splitting the x and y as a two portion. That is nothing but x train, x test, y train, y test. Right. So let me show how the data brought up here. Right. So for x train, I have the value 6.15, because actually these are independent variable, right? X is nothing but your independent variable. So I have 6.51. These are the columns. Okay, even I can show this way. Let's see. It's very, very important, guys. Okay. So I want to make sure you guys to understand bit and pieces, not just like run through the session. That's the reason I'm taking this much time. Oh, 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 oh. Okay, cannot do this one. Let me try. Okay, no attribute in this. Okay, fine, no problem. Okay. Yeah. Right. So let me go back and check what is X train, Y train here in my Excel sheet. What is that value? Mm, uh, 3.54. Not everywhere, but so this one. Let me filter this one, then it'll be easy. Oops. If you have any text, it will be easy. But since it's a completely data, right? 34. 134. It's really tedious job anyway. I'll try to show some points. 10.7, 10.11. Okay, there are so many values. So that is the reason actually we are getting this one. 0.93. Just I want to show how it is. Yeah. 3, 4. Yeah, correct. 54, we not couldn't see that. So here 42, 4251. So either I couldn't see full picture here, but this is your data, right? So this is your train data, and this is your test data. Okay, if you find out that, like, probably if you filter out like this, you can find out that. Why I want to show this one, all these values, right? Okay, probably you can explore yourself by filtering out. If you have a text value, it will be easy. Since it's come across all the numeric values, it's a bit tedious job to filter out that. Okay, so after that split like this, see all the data go back to some portion gone to train and some portion gone to test, and going back here, see here actually train, white train and white test. Okay, so we got all the data here. This is actually this portion, this quality, right? The quality vertical line is splitted into two portions, like as uh, test and train. Okay, so this is how actually we used to do that test and train splitting. So just I want to show how it is working. So is there any questions?
Sir,
So yeah,
sir, can't we convert
yeah.
this numpy array into data frame, sir? This extrain, X test.
Sorry.
So these extreme X test, no, sir. These values. Can't we convert it into
Yeah.
data frames?
Yeah, we can convert into data frame. Yeah, you can convert into data frame. Yeah, you can convert into data frame. You can do that. Okay, just for understanding. Generally, we won't do that. Generally, we won't do this step. This is for your understanding, and I showed. Okay, so very well you can convert in this array into data frame. That's fine. Okay, so how you did with the num array with the data frame, right? So we can convert that. So you can print that value. Okay, but same time you need to give the column value and all. Okay, that's a big challenge here. So generally, a real time scenario, nobody will do this statement.
Okay,
Okay,
sir.
this is not at all required across. If you go any machine learning algorithm implementation, why I show this? I want to show you to you guys how these are split across.
Okay, sir.
Okay, so
Okay,
that's
sir.
the reason I showed you guys. Like you can understand how this has been done. I've created my dependent variable, my dependent variable and the independent variable, right? So
Okay,
just I
sir.
want to understand, right? Independent variable and dependent variable. This is the independent variable, okay, and then this is my dependent variable. So after this allocation I'm not going to discuss with the data size. Okay, so I'll go take care only X. So the X I have all the columns. Here are going to be all the columns and values. And here quality only, one quality, one column. So that I can fit into here. So this one is actually one to one. But basically here we are doing one to multiple. Okay. So this
Okay,
is
sir.
going to be a chart going to be like this. Okay. So the relation is going to be like this. Okay. So it could be anything. Here it could be uh, this is the one-to-one relations, but what we are doing is totally different. X1. This is X2 and X3, X4. Got it?
Yes, sir.
So this is going to be a multi-dependent variable, right? The earlier one, what I did like this, nothing but single linear, the simple linear relationship. X2Y, that's it. But in our example, we have multiple what is that? Multiple independent
Independent.
variable. Yeah, I have other examples as well. I'll try to pull out that one. I created one very nice example. I couldn't get that. So probably I'll try to do that. Actually, just a simple one like purchasing the famous sample. I'll share the code as well. Okay. So at this moment we'll move on.
Yes, sir.
Okay. So
Okay,
so this is the way to do that. So after you do all your training set and data set, training the set and test the set, you can move on to the production. Okay. Before that, we can have validation. That as well you can do. Okay. So here, very important one. Why we are going for random splitting, right? So in the random splitting, I'm giving, for example, in my data set, if I have banana, apple, and green apple and red apple, okay, and orange, whatever the fruits collection. So in serial splitting, what happened? Look at this diagram. Here, the given data set, I'm splitting like this. First of portion I'm taking and second of portion I'm taking for test and train. If I go for test and train, what will happen? The most of the things going to be what apple. Okay. And there might be the not holistic view of like getting, I cannot do analysis. So I cannot get the exact um, what is that training. For example, if I'm giving the test in 100 MCQ, it's a mixed up one. So if I give most of the things that in the training during our class training. So during the test, if I giving something irrelevant, nothing related to what is that for, let's say, like nothing related to for example red apple. So what will happen? So you cannot able to perform, because that might be like lesser chance to predict the values or like analyzes the data. So if I go with the random sampling, so I can pick up the questions from here and there across by 100 questions. So what will happen? The visibility and the possibilities of getting the data across my 100 MCQ, so that you guys can answer the questions whatever it comes through in your test. And top of that, during your um, final exam as well. Okay, so probably I think need to change small way. Probably I can pull out all the banana over under here, so that in upper portion I have only red apple and green apple. If I don't find any banana over here, then absolutely my training is waste. Correct? You guys are agree? If it is going to be like completely is going to be green and red apple, and there is no possibility to analyze the banana. So, but if you're going with across the random structure, definitely there might be, I will get the banana and red apple or orange or whatever it is a possibilities to get all the values to do my training set. That is an idea. We used to go with random splitting. So random state is going to be one, means internally it will do some mechanism. Okay, that's a 1, 2, 3, something like that. It's randomly, it will pick up the value. Is a system will generate. So don't ask me what is 1 will do, 10 will do, 5 will do. That is deeper analysis. We don't want to go that. Okay, it's clear. It's clear why we are going for random sampling, why we are going for sampling, splitting the data.
Yes, sir.
Okay, good. Cool. Okay. All right. So here the other main things like why we are going for splitting. Okay, the data split into training and testing set. So basically, just I want to read these things because we are very, very important. So we used to split the data set into train and test in the machine learning process, and mostly they'll go with the 20/80 or else 75/25. That the ranges between this range for doing that practical purpose deployment perspective is going to be different. Okay, and then right, and then the most of the major amount of data will be spent on your model for like a model going to be very strong enough, and the rest of the data will go with the test model. That's what I said. Like so during the class session, if you're training the people for at least 60% of question, forget about the final exam. So just for test purpose, I can have the 40 questions in my hand, so I can do the I can get the ready people to do perfect. This is not actually giving a challenges to the what is that the students. For example, I want to make you guys to get more mark, more score. Then what I supposed to do? I need to train you guys well. Correct? Otherwise, what will happen if I'm going with the 40% of training and 60% is going to be test, means there is a possibilities of the people use some people do the performance well, some people not do well, because the training set is very, very less. Okay, but I cannot go ahead with the training going to be 90% and testing going to be 10% is unrealistic. There is no use of conducting test. You got my point, right? That's very, very, very important. Okay, so it's a very important one. And the same way, so we have to go with like mix and reuse the same data for training both and sex. So just go through all those things. Okay, and therefore you should have separate training and test subsets on your data set to do your model evaluation and model confirmation. Okay, That is very, very, very important. And here, one of the main thing, thumb rules, too much training data leads poor evaluation of model process. That's what I mentioned earlier. If I give 90 questions during the training, okay, and during the testing, people cannot perform anything. And too much of test data leads to poor training, right? So if 80% I'm giving to the test, then your training might be poor. Guys, actually, you are with me, right? I'm not confusing, because there are other chapters also to confuse you guys, and even I can confuse myself as well. There are other concepts are there, even the concept called confusion matrix. Okay, that we'll discuss later. But I think I know this is a very important thing. Too much of training data leads to poor evaluation of the machine learning process. So if it is going to too much of training, 90% you are giving a training means 10% going to be providing for testing. You cannot evaluate the model if it's a good or bad. Do you agree? The same way, if you go with 90% testing and 10% of training means again there is less training. During the test, you'll get fail, and you cannot choose the model. Correct? The prior one, you can adjust the time, training data. But if you're going with the 90% of the test data means it's absolutely waste of your effort. Then again you need to rework, right? And same way, even though you're going with the testing and splitting model, we have other methods called Bootstrap method. So pictorial presentation also like clearly indicating like what they're doing with the Bootstrap method. Bootstrap method is nothing but internally they're taking the 10 rows. So here I have a 10 rows. They're taking randomly they're taking for some set of rows here, and 7 here and 3 here. And same way for the Bootstrap 2, they're taking randomly, they're picking the another next 7 and next 8 and 2, something like that. So they're giving different way. The other one, the cross validation, this is like the other subject I want to discuss more in detail now today, because it's a separate session to cover. Any questions? Okay. And as I mentioned earlier, we want to split our data into train and testing. After the completion, there is a one more steps is there, that is a validation. Validations mostly the data science testers we used to do the testing. Okay, that is very, very, very important. Okay, so after you are performing your for ML model proof of concept, okay, point of value, then you have to be go ahead with the selection of model, and after the model selection, to improve the process, we have to go with validation. Okay, that and all we'll discuss very later. But when we are discussing those things a later point, you shouldn't forget this one, and by the time it may be surprising for you. That's the reason I'm trying to inserting all the data key points on the right away. Okay, like scaling, encoding, and muting the data, and all other things actually already we are discussed. So when we are going to the when you're going to the what is that the next level of there's some major things we are doing that. So by that time we'll pull out all the key what is that the keywords, so that it will be easy for you to try to dot the connect the dots. That's very important. Okay, right. Better I will show this one. Yeah. Anyway, we'll discuss about a linear regression later. But before that, just I want to okay. Today's session with linear model. how we are doing that. Linear regression. Okay, regressor is equal to linear regression. Just I'm creating one variable and I'm fitting that the regression, linear regression, by passing my x train and y train. This is very very important thing. Okay, this is nothing but I'm creating a linear regression model by using my linear regression method. So for the same, I have declared uh, my linear regression from your linear model SK learning. Okay, scikit-learn. So what I'm doing here, I'm creating linear regression regressor. You want to give input anything, you can put anything, not a problem. Okay, but meaningful way, and fitting the value. After the fitting that, I'm I'm finding out the what, predict the value of exit test. First I'm passing the value of exit train y train. I'm training. I'm training this value by fitting this value x train in y train. Why I'm giving x train y train? My independent variable and dependent variable. Internally it will do all these things. Forget about that. If you want to do that, I have the number of slides with me, how this the basic linear integrations, linear regressions will work. That is very simple. X y, x square, y square, x minus y the whole square, summation of that, you know, that formula, right? So that formula calculations we have a slides. If you want, I can share the slides. From that mathematical calculation, it will arrive the fitting the curve. Okay, but the Python library, scikit library, providing the simple function, a one line function to get out that fitting that train and test data to draw the this specific line. Okay, so like this. See, let me remove this. Okay, so automatically what will happen? So this will create a one other one. Oops. Here we have some calculation. O is equal to mx plus c. So probably if you guys get a time, just go through your linear equation max book. So there you can see some tabular column. I don't want to draw over here. That is going to be the given value x, y, and x square, y square, x bar, y bar, and sum of summation, some formula. So that will take care by this specific line. Okay, fit and predict. So this will predict the value. Okay, predict the value. And here, what I'm doing, I want to compare the test value and predict value. Okay, so this is going to be a finding, guys. This is very important because, see, simple way I'm telling. For x2, y here, and some value here, some value I'm putting here, and some other value I'm making points here, right? But I have x value something here, then I want to value of y, I want to predict here, correct? So this might be 1, 2, 3, 4, 5, 10, 20, 25, 30, 45, something, some ranges. So all it has the equivalent value of y. What is that? That is nothing but, forget about all other factors. Just think about only. Okay. So until, okay, let's say I'll go at the top, right? Fixed acidity 7.1 means quality is a 5. Forget about internal independent variables. Let's say for fixed value of 7.1 for acidity value, quality is 5. If I want to predict the value of 8 acidity value, what going to be the quantity? Okay, what's going to be quality? Then I want to draw something here. Then I want to predict the line. Okay, so I need to use that the linear equation formula, and you need to apply. Then we will get the value. Guys, I think hope you remember. You have x, y value. Okay, there might be a number of values given here, 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 and here. Better you just go through a linear equation mathematics book so you can understand. So for the specific x, what is value going to be here? So there might be a big formula. You need to find out x square, y square, x bar, y bar, and summation of blah blah blah. So many things we need to find out. M and C, all the things we need to find out. Finally, you will get some value that is nothing but for this x6 is equal for 6. You will get something like that 7.28. I'm really sorry, I'm not able to write this. Okay, so if I'm getting this value, what is the value for 6 means after the big calculation, we used to arrive this value 7.28. For example, I'm saying. But if you're using this linear equation of the Python and regression does predict of x text value passing and y predictor is a new variable, and I'm making the array is like the data frame, like what is that data frame of actual versus predicted. So I will get this value for my predicted value of 5. This is going to be a 4.95. Okay, and this is a nice chart. Sorry, in actually in data brick, if you can open this chart, but even you can save the chart. I don't want to explain here. Okay, so you can find out the chart actual predicted. Okay, and I want to validate. I want to validate few things here. How much percentage like so here we have means absolute square error and mean squared error and a root mean square error. These are the very important parameters like from validating your model. Okay, so how it is strong? So by using this one, is this nothing but actually root mean square is nothing but 60.657 is nothing but 65%. So your model is 67%, absolutely correct. Okay, I have the other program. I don't have a time now to pull out that. It was somewhere in my list. I couldn't figure out that. Okay, so I'll explain probably in the next class. So in that sample, you can figure out how predicted and actual expectations align with your mean square error. Okay, so these are the actual value and this is a predicted value. So we are expected 5.6 is going to be a predicted. Sorry, yeah, actually it's going to be a 5. And here we are predicted 6.7, sorry 6.3, and the actual is going to be 7. Right? So that's very important. So probably we'll see the rest of the things by next week because the rest of the things is a bit overloaded because this is going to be overfitting, underfitting, other stuff. Let me show some other samples as well. Okay. So it's a simple example. Okay. So I'm loading my library, and this is my auto MPG CSV file. Okay. And I'm loading my data. I think I don't explain again. And here I have origin. Okay. So origin is going to be here, but for this is not required at this moment because we are changing the value. But again, we should change the value in the below one. I don't want to explain this one. So creating a dummy value. So creating dummy get I'll explain this one later because we have a get dummy, encoding, hard coding, one hard coding. All I think we have gone through that get dummy value when we are working with the category variable. I think hope you remember that. Okay. So if you want, you can just go back to your the recording videos. So there we have explained like dummy get dummy values, so that all the categorical variables is converted into this all categorical variables, right? They're converting one is nothing but America, then two is going to be Europe, and three is going to be Asia. So all the value is going to be converted into the numerical value. So yearly it was categorical variable. Okay. So after converting this categorical variable, so what they're doing, they're just describing, forget about this one, and they're finding the data type. Okay. So you know that already. And then these are the small functions. I think we don't know these digits or something like this. They're doing some EDA, that is a data explanatory process they are doing. Okay. So just you go through this code, probably you can understand what exactly is it. And they are replacing with the question mark for like a none value. Okay. And then very important bivariant plots. So probably you can find out like what is the correlation. Here the MGP is mostly positive with respect to your model here. Forgot about that. So mostly horsepower, horsepower and height going to be a positive linear, and weight and horsepower is in positive direction, right? So these are the key area. And coming to the split and training split. So what they are doing, they're taking, they're dropping that the Europe region, and this is another way. This is very important key one note. Again, I want to highlight here. If you take this example, if they take the, because actually I need the quality for my dependent variable, and other variable want to be in independent variable. Okay. So that is very tedious job for getting my independent variable, right? So independent variable almost all the variable, but if you excluding your dependent variable, the rest of the things going to be what your dependent variable. You got it. See, for example, I have a column A, B, C, D, E, F. Okay, and G. So here, if I want G is equal to going to be my independent variable, then all other variables going to be my all are going to be my dependent variable. Okay, these are the independent variable, and this is independent variable, dependent variable. So either you can exclude this one, or else you can, if you exclude this one, automatically you will get all your independent variable. So that's the reason in example one, I mention all my dependent variable, okay, my independent variable here, so that I can excluding only my independent variable quality. But if you exclude directly my dependent variable here directly MGP, forget about origin. Okay, but I should remove earlier. I don't want this, but no more, not required. Let's say. Okay, so here I'm dropping only this column for this one, and here I'm mentioning only this column. It means drop only MGP and consider all other column for my independent variable, and y is equal to MGP is nothing but just only this is going to be my dependent variable. So no need to mention all the way of all column by separated by comma. This is unnecessary job. And same way here also I am splitting the value 3070. I'm doing my x print y print, sorry, x train y train. I'm getting all these values, and then I'm fitting my curve. So I'm getting all my regression values and test values, what it is. See here, my regression, train data, and test data. Okay. So in the next class, what I will do, I'll create the other samples to validate with the some standard format. So how we are going to validate with the standard format for the output, and the rest of the linear equation for some other sample, and classification, and the other linear sorry other